Now, when our parabolas do not have vertex at the origin, we just need to do a little shift. And the shift occurs the way that we would expect it to. Okay, we just replace x with x minus h and replace y with y minus k in the equations that we have, and that is where our parabola has a vertex at hk. So let's look at our example. Graph the parabola given the equation x plus 1 squared equals 8 times y minus 3. So let's go ahead and start by graphing what we know right off the bat. We know our vertex. Okay, our vertex is at negative 1, 3. So negative 1, 1. There's our vertex. Okay, then we can find p by saying, well, we know 4p is this number in front of that y. So 4p is equal to 8. Therefore, p is equal to 2. Now it's positive, and because the x is squared, this is a vertical parabola. So from my vertex, I can go up 2, 1, 2, and there's my focus. And from the vertex, I can go down 2, and that is my directrix. And I can sketch the parabola. So just what we've drawn, we can go ahead and write some things. So our vertex was at negative 1, 3. Our focus is at negative 1, and then we added p to that, so 5. Our directrix is y equals, and then it was 3 minus 2, which is 1. And we want the length of the lattice rectum. So we need to find the endpoints of the lattice rectum. So that's when y is equal to 5. And so if we go up here and plug in 5 for y, we can then solve for x. So we've got x plus 1 squared equals 8 times 5 minus 3. So that right there is 16. And then if we take the square root of both sides, we get x plus 1 equals plus or minus 4. And then subtract 1. We get x equals, well, if we take negative 4 minus 1, we get negative 5. And if we get positive 4 minus 1, we get 3. And the length of the lattice rectum, length of the lattice rectum, well, that's just the distance between those two numbers, which is going to be 8. And you'll notice that that's simply double this number after we took the square root there, and that's always going to be the case.